Welcome everyone. Today we're going to learn how to do linear regression in Pytorch on a data set which is available on Kaggle. So it's not going to be like conventional whether we're going to display each and every. I will explain each and everything making a customer data set. I will actually perform linear regression on a data set which is available on Kaggle. It's a great code. Develop a passion for learning. If you do, you will never cease to grow. Okay, so introduction. Linear regression, everybody there y is equal to a plus bx, where x is the exponential variable and y is a dependent variable. X is input, y is target, slope of the line is b, and intercept value y when x is equal to 0. So basically, you can see linear regression is a straight line. Actually, it's a straight line fit between the two variables. To do this, we will use a mean square error loss generally defined function prediction from the correct answers. In regression, we usually focus square error, especially over some example. Actual input, predicted output, y hat, a mean square error. Okay, so let's get started. First of all, you're going to import some libraries: NumPy, Pandas, Torch neural network, optimizer, pilot, SNS warnings, and plotly. So here, if you can see train, we're going to set the train path as we importing the dataset. Now the train dataset drop and a remove missing the values. Remove the missing values from the dataset. Over here it says splitting label into feature X train, Y train. I will show you in a moment that why it is important. Let me show you. Print train. If you can see the train value, you will see that 0, X and Y. X is equal to input variable, Y is equal to target variable. So we want only X. So that's why 0. We ship values. If you can see now, if you can a X train. So what's value stored in X train, right? Train variable stores this information like 3 columns. And what does value store in X train? So X train stores only value of the X column, the first column. Similarly, if you can print the Y train, you will see the value of the Y in that. Okay, so big. Now it's the test variable. It's a test the data set, and over here you can see head. You can see the shape of the train set is 1398 train 2 column X and Y, and test says 600 input variable X and Y. Count describe function will count means and deviation minimum 50%. These are the function. It will count total variable X has 6299, the mean of the all over variables and deviation. So this is the thing we can use by describing. Okay, so now we got our data, but we have to pay NumPy. You have an array that has 3 dimensions, right? It's technically speaking a tensor. A scale is a single number but has 0 dimension. A vector has 1 dimension. A metric has 2 dimension. Two matrices, and tensor has 3 or more dimension. If it has input which is more, it's called tensor. How you can change your vector into a tensor, the numpy thing into a tensor. So here it's a function torch dot from numpy xtrain dot float. It will take all the value and convert it into a tensor. Let me show you if I can print. X. Hmm. We have some idea. Oh, sorry. See, it just converted that that value into a tensor. Pretty good, huh? Okay. Over here we are preparing the tensor dataset, X tensor, Y tensor dataset for train, etc. of test. How to assign data loader is a function from the torch library. It will load your data and you can oversee, you can set the batch size. Making a model. Okay. Everybody knows that while regression is equal to y is equal to mx plus c, in which you have a model and you have a loss function and you have optimizer. But do we really, it's just a generic function within a function. It turns in iterative, right? So we're just defining a function which has the model, which has a loss function, which has optimizer, and we return it at epoch. Over here we're defining some model, loss and optimizers. So, and over here we're training step, call this function, and for each function it will take the batch, compute the loss, uh, compute the loss for the each function, and similarly for the test case as well. So if evaluation, over here you can see the test loss is decreasing. Surprisingly, the training loss decreased right straight away from and then it gets stuck. If you can see that line has been fixed. So that's it. You can use this code and apply it on other data set and see what happens.